Hello sir, I am Inamul Haque Mondal from Electrical Engineering Department second year. Today is my topic is diode operation characteristic. Next, operation and characteristic. Diodes are fundamental semiconductor devices that play a crucial role in electronic circuits. They allows current to flow in only one direction, making them essential components for rectification, signal modulation and voltage regulation. This presentation will explore the basic structure, operating principles and key characteristics of diodes. Next, basic structure of a diode. PN junction. A diode consists of a PN junction where a p-type semiconductor material is joined with an n-type semiconductor material. This junction is the fundamental structure that enables the unique characteristic of a diode. Depletion region. At the PN junction, a depletion region is formed where the majority charge carriers have been depleted, creating a potential barrier that allows current to flow in only one direction. Diode terminals. The n-type materials is connected to the positive terminal known as the anode, while the n-type material is connected to the negative terminal called the cathode. Next, diode operation forward bias. Positive number one point is positive potential, where a positive potential is applied to the anode and a negative potential is applied to the cathode. The diode is said to be in forward bias. Second point is depletion region narrowed. The applied potential reduces the width of the depletion region, allowing a large amount of current to flow through the diode. Number 3 is conduction state. In the forward bias condition, the diode is in a conductive state, allowing current to flow freely from the anode to the cathode. Next, diode operation reverse bias. First point is negative potential. When a negative potential is applied to the anode and a positive potential is applied to the cathode, the diode is said to be in reverse bias. Second point is depleting region wind. The applied potential increases the width of the depletion region, significantly reducing the flow of current through the diode. Number 3, non-conductive state. In the reverse bias condition, the diode is in a non-conductive state, allowing only a small amount of leakage current of flow. Next, voltage current characteristic. Forward bias. In the forward bias region, the diode exhibits an exponential increases in current as the applied voltage increases, with a characteristic threshold volt where conduction begins. Reverse bias. In the reverse bias region, the diode allows only a small amount of leakage current until the breakdown voltage is reached, at which point the diode experiences a sharp increase in current. Breakdown voltage. The breakdown voltage is the point at which the diode's depletion region experiences avalanche breakdown, allowing a large reverse current to flow. This is an important parameter for application like voltage regulation. Next, Diodes type and application. LEDs are diodes that emit light when forward biased, making them useful for various lighting and display applications. Generator diodes are designed to operate in the reverse bias breakdown region, allowing them to be used for voltage regulation and stabilization. Next, Schottky diode. Schottky diodes have a low forward voltage drop, making them suitable for high-speed switching and rectification application in power supplies and RF circuits. Rectifiers diodes are used to convert alternating current to direct current in power supplies, battery charges, and others electronic circuit. Next, practical consideration and design tips. First point is voltage rating. Always ensure that the maximum reverse voltage and forward voltage rating of the diodes are not exceeded to prevent damage. Second point is current handling. Consider the diode's maximum forward current and peak reverse current rating when the designing currents to avoid overloading the device. Third point is thermal management. Proper heat sinking may be required for high power diodes to dissipate the heat generated during operation and maintain reliable performance. Number fourth is circuit protection. Use protective resistors, capacitors, or other components to limit voltage and current spikes that could potentially damage the diode. Next, conclusion. Diodes are fundamental building blocks of electronic circuits, playing a crucial role in power supplies, signal processing, and various other applications. Understanding the principles of diode operation, their characteristic, and practical design consideration is essential for electrical engineering and students to effectively utilize this versatile semiconductor device. And last of all, thank you, sir.